So let's get started. If you remember, and if you don't remember, that's fine. Today we're talking about the sum and difference formulas. So we're doing part 2 of 9.2, which are all of these stuff. And we used them a little bit, and now we're going to use them a lot. All right, so we're on example, I don't know, it's example 6 in my notes. It'll be example 6 for you, whether you like it or not. We are going to say that given, I love these problems, but some people don't. Given that sine of alpha is 3/5, so again, automatically we know this is a 3, 4, 5 triangle right here with alpha, one of the angles. And cosine of beta equals negative 5/13. So again, this is going to be a 5, 12, 13 triangle in one of the quadrants. We don't know what quadrant this is in. Cosine is positive in the first and fourth quadrant, so we know that beta has to lie in either the second or third quadrant. And again, I don't think we've used alpha and beta yet in this class, but alpha just looks like a little fish thing, kind of like an A. And beta, people write betas differently. I kind of just write a B with a really, really long tail. But you can just use A and B if you want. It doesn't matter too much. Anyway, this is good. Oh, nice. The problem tells us. And the problem tells us that beta is between pi and 3 pi over 2. So, right, what quadrant does that mean it is? It's more than 180 degrees, but it's less than 270 degrees. It's in the third quadrant. Okay. Anyway, find the following. Part A, what is the sine of alpha plus beta? All right, and real quick, I'm going to stop you right now, because I know what I've seen before. You can't just say, oh, sine of alpha plus beta is just 3/5 plus 5/13, negative 5/13. No. We can't do anything. We don't know anything about alpha and beta. You could approximate it, but we want to find this exactly. So we don't really know what alpha and beta are exactly. We're going to use an angle sum formula. Okay, so we go to our angle sum formula, find it. Again, you'll always have these available on stuff. So the sine of u plus v is this plus that. Remember, plus or minus, which means plus over here means plus over here. So this says that it's going to be the sine of the first angle, which is alpha, times the cosine of the second angle, which is beta, plus the cosine of the first angle, which is alpha, times the sine of the second angle, which is beta. So again, this is the only thing that's new in this section, that one step. And now we rely on all of our previous trig knowledge to move on. So this looks easy, right? Sine of alpha, we said was 3/5. Cosine of beta, we said was negative 5/13. Plus the cosine of alpha. I don't see the cosine of alpha. Well, guess what? It's a throwback to chapter 7. We know how to find the cosine of alpha. We don't know it yet, but we can find it. We know that the sine of alpha is 3/5. And again, we really need to be told where alpha is. Alpha is in the first quadrant, right? So if alpha is in the first quadrant and the sine of alpha is 3/5, we have this sort of situation. Okay, so if you're good, you could use the Pythagorean Theorem, a squared plus b squared equals c squared, or remember just 3, 4, 5 triangles are special triangles. We're not going to spend time. So the cosine of alpha is the adjacent over hypotenuse, is just 4/5. Ah, there we go. How about that? All right, times the sine of beta. We're not given the sine of beta. Let's find it. We said beta was in the third quadrant. And we said the cosine of beta was negative 5/13. Again, hypotenuse is always positive. And it's negative here because we're in the third quadrant, so the x-coordinate's negative. And again, this is going to be negative 12 by the Pythagorean theorem. The y-coordinate's negative, hence the negative. And it's a 5, 12, 13 triangle, or you could use Pythagorean theorem. So the sine of beta is negative 12/13. Oh, this is not so bad. Now we just simplify a bit. So this becomes negative 15/65. Multiply the tops, multiply the bottoms. And this becomes a 48/65. Negative 15 minus 48 is going to be negative 63/65. That's the sine of alpha plus beta. And you might think, ugh, this problem sucks. This was only part A. We're going to have to do this 3 more times? Well, we already did all the hard stuff. Now it's easy street. If you did part A correctly, parts B, C, and D are going to be a breeze. All right? So here's what I mean, right? For part B, let's keep this showing. Now I want you to find what the cosine of alpha plus beta is. So again, we don't know what alpha and beta are right now. We could approximate them with calculators using inverse functions, but we want exact answers. So we can't just add these angles together, and we can't just say, this is definitely not cosine of alpha plus cosine of beta. Definitely not that. Think of any rule that you like to do with functions and throw it out the window for trigonometry, okay? For trig functions, most rules don't apply. If you want to know what you can do with trig functions, it's right here. Okay, all of chapter 9 is, hey, how do we deal with this stuff? So we need to find out what cosine of A plus B is, or alpha plus beta. Remember, cosine is a plus minus over here, which means a plus minus plus here. A plus on the inside means a minus on the outside. These are going to have opposite signs. Cosine, the product of their cosines, minus the product of their sines. Okay, so this is going to be cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. And here's where things get really juicy and you're going to feel like, oh, so relieved, right? Is that we already know all this stuff. Cosine of alpha, oh, we said the cosine of alpha, oh, I need to label this one. This is beta. Cosine of alpha, we said was 4/5. Ah, there we go. Times the cosine of beta, which we said was negative 5/13. That one was given. Minus the sine of alpha, 3/5. Times the sine of beta, negative 12/13. Again, only this step is 9.2. Everything else is just simpler stuff. Like this step right here is just plugging in things we already know. So we're going to get negative 20 over 65. We could simplify that, but let's wait to simplify because we need a common denominator. Minus minus makes a plus. 36 over 65. Negative 20 plus 36 is going to be 16 over 65. And this doesn't reduce at all because 16 is just 2 to the 4th power. This only has 2's in it, and this has no 2's in it. You know, 65 is not divisible by 2 because it's an odd number. To be divisible by 2, it has to be even. All right? And so there's something really, really tricky here. It doesn't have to be tricky, but tangent of alpha plus beta. If you really want to impress your friends, here's a little trick for you. We could go over here and say, okay, tangent of alpha plus beta is going to be tangent alpha plus tangent beta, 1 minus tangent alpha tangent beta, and simplify that. We're going to have complex fractions. It's going to be a bit of a headache. We're going to have to do this later anyway. Or watch this. We don't even have to use this angle sum formula because tangent of any angle is the sine of that angle divided by the cosine of that angle. So even if the angle is alpha plus beta, it still holds. So if you want to use the angle sum formula, be my guest. But if you want to save work and don't write as much and go home early, let's do this. Yeah, we talked about this in 9.1. This is the sine of alpha plus beta, which we already found, divided by the cosine of alpha plus beta. Small side note, on a quiz or an exam, if you have extra time, I would do it both ways. Do it this way and do it with the other formula. It's a great way of checking your answer because you have 2 different answers for part C that should be the same. And it's a good way of checking your previous answers. If your previous answers are wrong, but use the angle sum formula here, then they won't match. And it'll give you a good indicator that something's up. Okay, so the sine of alpha plus beta, we found that in part A. We said that was negative 63 over 65, divided by the cosine of alpha plus beta, which we said in part B was 16 divided by 65. And I want to finish this problem on this paper, so I want to kind of go over here into the corner. Remember, division of complex fractions. You can either multiply the top and the bottom by the LCD, which is 65, or take the top and multiply it by the reciprocal of the bottom. So let's do 65 over 65. It's going to cancel with the denominator on the top, and that one's going to cancel with the denominator on the bottom. We're left with negative 63 over 16. Oh no! I really need to get a new pen. All right, and that's our answer. Much quicker, right? So, if you remember, by the way, one way of figuring out what trig functions are positive in which quadrant is this ASTC, alto, soprano, tenor, bass. I don't know. Any way you want to remember this, there's a bunch of them out there. So notice our sign is negative, so we must be either in the third or the fourth quadrant. Cosine is positive, so we're in the fourth quadrant. Tangent's negative, yep, fourth quadrant. So we know that alpha plus beta is in the fourth quadrant. Alpha is in the first quadrant, beta is in the third quadrant, and their sum here is going to be in the fourth quadrant. And we can know that by looking at these trig function values. All right, so here's where things get a little bit something else. Part D. Part D is the book. Is really the book saying, I know you guys like shortcuts, but that's enough. Can you use this tangent formula? Because unfortunately, right, tangent of alpha minus beta is sine of alpha minus beta divided by cosine of alpha minus beta. But unfortunately, we don't know the sine or cosine of alpha minus beta, whatever that angle is. So we're really going to have to just use a formula this time. So we go over here, find the formula. If there's a minus, that's on the bottom. So we choose everything on the bottom, which means minus on the top and a positive on the bottom. Okay, so our handy dandy formula sheet, which you'll have access to all the time, says it's going to be the tangent of the first angle, and then same sign minus the tangent of the second angle, divided by one opposite sign now, so it's going to be a plus tangent of alpha, tangent of beta. And unfortunately, we haven't found what tangent of alpha is or what tangent of beta is, but we have these handy dandy little drawings. Tangent of alpha is 3/4. Tangent of beta is opposite over adjacent, 12/5. 3/4 and 12/5. Okay, so we said this was 3/4 minus 12/5 divided by 1 plus 3/4 times 12/5. And I'm going to be honest with all of you. These tangent ones are the worst, especially when you're dealing with radicals, because then you want to rationalize the denominator here. But even now, we're going to have complex fractions. So again, there's a bunch of different ways of dealing with this. One way of dealing with this is multiplying by the LCD, my preferred method. Or you could combine and multiply and divide by the denominator. So LCD of 4, 5, and 20 is going to be 20. Multiply the top by 20 and the bottom by 20. And if you want to think about it, this is 20 over 1, you can. Because it's only going into the numerators of the top. So, nothing to do but grin and bear it. This is going to be 60 over 4. We multiply by 20 over 1. Minus 240 over 5. Divided by, distribute on the bottom, 20. Plus, the denominator is 20 here. I'm going to kind of cheat a step. It's just 36. The denominator is going to cancel on this one. All right, and let's just reduce. 60 divided by 4 is 15. You can always have a calculator as well. 240 minus 5. I really should have just done it the other way. It should be 48. And your denominator is just 56. Oh, this is not bad. So what's 15 minus 48 is negative 33. Can this reduce? The numerator is only 11 and 3. The denominator is like 8 and 7. No, all right, it's not going to share anything. Great. So that's what happens if you have to use the tangent formula. So notice, I really want to just show this off. Look at this beauty. Complex fractions, whole bunch of algebra. Again, the hardest part of this chapter is going to be algebra. Only this first step is 9.2. Then the second step was chapter 7. And then a whole bunch of algebra. And again, you can use your calculator once you get here as long as you can type it in correctly. Anyway, So 1, 2, 3, 4, 5-ish steps. Or if we already have sine and cosine, it's super quick. So super quick is good. Longer, also good, but sometimes less fun. All right. And that's example 6. It's a fun one. There's a high likelihood of something like example 6 being on a quiz. We'll see. All right. So most of you have probably already taken your second exam by the time that you watch this video. And on the second exam, oh, sorry, I skipped example 7. We don't want to skip example 7. It'll get lonely. So this is short, random example. You're going to feel relieved when you see this. Write the tangent of pi divided by 9 in terms of its cofunction. All right. So this is just a small reminder of different things that we can do. So remember cofunctions. The tangent of some angle is the cotangent of its complement. Complement just means add up to pi over 2. We can also write it like this. So we need to find the complement of pi over 9. So the question is, what plus pi over 9 equals pi over 2? Well, subtract pi over 9 from both sides, get a common denominator. This is going to become 9 pi over 18. This is going to become 2 pi over 18. We're going to get 7 pi over 18. So that's the complement. So we just use the cofunction identities, that the tangent of pi over 9 is the cotangent. Wow, I'm writing out the whole word. The cotangent of its complement, 7 pi over 18. All right, so that's all we're doing here. Just a little reminder. And now we can go to verifying identities, because this is what people love. If you asked a random person who's taken a trig class at the college, plural, let's do this plural, what their least favorite part of trig, they're probably going to say verifying identities. Not because verifying identities sucks, but because it's hard. Okay, and most people don't like things they're not good at, myself included. So let's do this. Let's get our hands dirty. Example 8, verify. Part A, the sine of alpha plus beta plus the sine of alpha minus beta equals 2 sine alpha cosine beta. So we start with the messier side, and specifically, starting with the left-hand side is a really good idea because we know we've got great looking identities for the left-hand side. All right, the angle sum for sine and the angle difference for sine. So let's start with the left-hand side and go on a little journey and see if we can get the left-hand side equal to the right-hand side. So sine of alpha plus beta, we use identity sheet. That says sine of the first, cosine of the second, same sign, plus sine of the second, cosine of the first. All right, and actually you'll see what I did right here. I did it this is in a different order, these two right here, than what's on your identity sheet, but it's equivalent. But sometimes when I don't look at the identity sheet, I flip-flop back and forth. But it's all the same. All right, plus the angle difference. Sine of the first, cosine of the second, it's supposed to be a plus sign. Now minus the sine of the second, cosine of the first. So notice what we have here. The first and third terms are exactly the same. Right? If you have an something plus another something, well, now we have two of those things. If this is an apple and this is an apple, we're adding them together. We got 2 apples now. So look at this term and that term. We're getting 2 sine alpha cosine of beta. Whoa, my beta turned into an R real quick. And then what else do we have here? Well, we got the second and fourth term. Sine beta cosine alpha minus sine beta cosine alpha. Wait, we've got one orange. We take away we have one orange. We take away an orange. Well, now we have 0 oranges. So you could write a plus 0, but you don't need to. What the? This is the right-hand side. I'm so angry. That was too easy. Too easy. All right, but that's the idea. It looks awful, but as soon as you do the right step, which can be hard to do, it all comes together. They're not always this easy, but don't be too intimidated with a lot of this stuff. Just try some things, okay? Let's do a part B, since I know that part A was not good enough for you. Sine of alpha minus beta divided by the cosine alpha, cosine beta, equals the tangent of alpha minus the tangent of beta. Again, alert sounds, alarms going off in your head. You think, oh, tangent of alpha minus tangent of beta, we have an identity for that. No, we don't. We have an identity for tangent of alpha minus beta, not when there's a subtraction on the outside. There's no identity for the left-hand side that I know of. Okay, I'm sure there is one somewhere. You could make one. So what are we going to do? We're going to start with the left-hand side, because the left-hand side looks really juicy. All right, start with the juicier side. And again, it looks awful, but don't worry. Let's use our identity. This is going to be sine of the first, cosine of the second. Again, this difference formula says same sign here, so it's going to also be a subtraction. Minus cosine of the first, sine of the second, this is not looking good, divided by the same denominator as before. Oh no. This doesn't look good. I don't know any identities I can use right here. I scour my sheet, no identities to be found. Sometimes when you get lost, look at where you're trying to go. The tangent of alpha minus the tangent of beta. Well, remember, tangent is sine of alpha over cosine alpha. Sine of beta over cosine beta. So this is essentially two fractions on the left, or on the right, where we have one fraction on the left. Let's make two fractions. All right, so it's going to be the first thing, sine alpha, cosine of beta, divided by our denominator, cosine alpha, cosine beta, minus the second thing, cosine alpha, sine beta, divided by the same denominator, cosine alpha, cosine beta. And you might be nervous, thinking it doesn't look better, but look at what we got. When we turn on our algebraic minds, we got the cosine of beta over cosine of beta. Aha! Cancel. Everyone loves canceling. Cosine, canceling again. What are we left with? The sine of alpha divided by the cosine of alpha. I know what that is. That's the tangent of alpha. What are we left with over here? Sine of beta over cosine of beta. That's the tangent of beta. Well, isn't that exactly what we wanted to show? 1, 2, 3 steps only. Just have to watch out for your algebra and evaluate these, use these identities correctly. These problems are so much fun. These are my favorite trig problems, actually. So I'm sorry, I get a little excited. I enjoy this. All right, there's only 2 problems left in this video. They are like puzzles, yeah. You start with something, you've got some tools, you know where you want to go, you just got to get there. So, time for everyone's favorite part of a section, applications. I know all of you are thinking, well, when are we going to use this? Well, maybe you won't, but here's when some people use it. The first one's kind of an abstract example. You're not going to like the first one, I already know. The second one, though, is more interesting, I guess, sort of. I don't know. These are kind of weird examples. I'm not hyping them up very good. I want to go back to verifying identities. Anyway, here we go. Example 9. Show that the tangent of theta is, you're not going to like this, m2 minus m1 divided by 1 plus m1 m2. So I haven't told you what this stuff is yet. We haven't gone into the application yet, but this should immediately look familiar. Something minus something divided by 1 plus a product. It looks a lot like this. Looks a lot like angle sum or angle difference, specifically angle difference of tangent. But again, I haven't told you what's going on yet here. I've got my cat playing some super weird game over there. Here we go. Let's continue on. Where mi is the slope of li. So this is just shorthand, right? I can be 1 or 2. So m1 is the slope of the first line. m2 is the slope of the second line. And we've got a nice, beautiful drawing for you of a line. Let's call this the second line. Why not the first one? No idea. And this angle, the angle of the second line with the x-axis. All right. And then let's have another line, a second line that we're going to call the first line. All right. And we have theta 1 right here, the angle that makes of the x-axis. All right. So this, so again, the slope of this line is just going to be m2. The slope of this line is just going to be m1. So really, and this problem does give you a hint, right? The hint is to express theta, let's call theta this angle, in terms of theta 1 and theta 2. Okay? And it's a double hint, the hint that keeps on giving. Express tangent of theta 2 in terms of m2, the slope. So let's think about all this. This is a complicated example. There's a lot going on. All right? We have 2 hints. Let's just think about the hints. First off, let's look at this angle. How can we express this angle, the angle between these, in terms of the other angles? And again, I kind of already hinted at this because I said this kind of looks like the difference of angles for tangent. But again, notice that if we draw a parallel line with the x-axis, think of a little parallel line right here. This angle is all of theta 1, except we're losing part of theta 2. This angle right here is theta 2, if you remember back to your geometry days. Okay? So it's going to be theta 1, the whole angle. Oh, not the whole angle. We're only going to here. Theta 1, the big angle, minus the small angle, theta 2. Okay? So use step 1. Theta is equal to theta 1 minus theta 2. Okay? So we dealt with the first hint. We'll use that later. Second hint, express the tangent of theta 2 in terms of its slope. All right, so what do we have right here? Let's blow up this picture, right? We have a line right here. Let's look at line 2. We said this was theta 2 down here. Well, what is slope? Slope, right, is the rise, or y, over the run, which is x. Rise over run, y over x. Wait a minute. That's tangent, right? This is just tangent, right? Theta, tangent of theta 2 is the rise over run. And by golly, we've used the second hint. Tangent of theta 2 is rise over run. What's rise over run? The slope of that line. Well, now this problem doesn't look so hard. I mean, it still looks kind of hard. Who am I kidding? But it's not as hard as it looked, because we need to show that the left-hand side equals the right-hand side. So let's start with the left-hand side. What's the tangent of theta? Use the hint. Theta is theta 1 divided minus theta 2. So that's going to be tangent of theta 1 minus theta 2. And now we need to work with this using an identity, yeah. Using identity, so we go over here. We need to find the difference identity for tangent. So a minus, this is going to be same sign on the top, so a minus on the top, opposite sign on the bottom, so a plus on the bottom. So it's going to be tangent of the first minus tangent of the second divided by, now opposite sign, 1 plus tangent of the first times tangent of the second. Well, now we use our second hit. Tangent of theta 2 is just m2. Likewise, tangent of theta 1 is m1. So tangent of theta 1 is just m1. Minus tangent of theta 2, which we said was just m2, divided by 1 plus tangent of theta 1, which is m1, times tangent of theta 2, which is m2, and... whoa, that's exactly what we wanted to show. All right, so we showed it. We did it. Got a nice whole page problem for all you. All right. The higher you go in mathematics, the longer your problems become. But, you know, it's kind of a fun little, I think it's kind of fun. You don't have to like it, though. It's okay. Luckily, math is a fun activity you can do all by yourself. So I don't need you guys to love it like I love it. Let's do the last example of this section. And again, your homework's going to be due next week, I believe. Next week, Thursday, a week from today. All right, so find, this one's funny. So essentially, all this is saying is find alpha. All right, and there's a whole application for this, but I really didn't want to write it all out. I can show you guys, though, since I do just take these from the book. I think it'll be a good idea. But essentially, we've got some kind of tower with some guy wires. I didn't even know what guy wires were, but I read about them. And so now I guess I kind of know. And we're given some things, and we have to find some other things. And honestly, this problem doesn't even have to use 9.2. If you really don't like 9.2, you don't even have to use it right here. So let's check this out. So we got a guy wire right here. These two wires right here on a tower, which apparently they're helpful. Oh, it's a pole for helping that up. We know that the first wire attaches at 40 feet above. We know the second wire attaches at 47. We know how far the wires are from the base, 50 feet. We don't know what either of these angles are, though. All right. And what we want to find is what alpha is. So again, we can't just say sine of alpha is 7 over 50, because this triangle, this orange triangle, is not a right triangle. Okay? So we're going to have to use some creativity. So I'm going to draw my picture. It's always a good idea, any application problem ever, to copy your picture down. And if you don't have a picture, draw it. So alpha is this little guy. It looks really small. And beta is the big boy. You might think alpha would be the big boy, but I don't know. Betas are in right now, I guess. All right, and 50 feet is a horizontal distance. 40 feet is the small distance, and the big distance, the beta distance, is 47 feet. Okay, so we know that, of course, the small distance is 7 feet. So we need to find alpha. So here's where this is kind of silly, because I see this problem, and maybe you see it the same way. So I say, well, let's not worry about doing anything too complicated. Let's just find what this big angle is, find what the small angle is, and then alpha is their difference. But if you really want to use trigonometry, you shouldn't do that. If you want to do 9.2, don't do it the way I want to do it. All right. I don't know. It's interesting. It's so dumb. Hold on. We're not doing this 9.2 way. We're going to do it the way that makes sense, because honestly, I'm not going to bend over backwards to write this as an angle difference. Writing this as an angle difference would just be ridiculous. Okay. So we have two triangles, right? We need to call this other little angle. Let's call it gamma, alpha, beta, gamma. All right. You could use theta. You could use phi. You could call it A. You could call it igloo. You could call it, I don't know, teriyaki. Doesn't matter what you call this angle. So then alpha, right, is the small angle, and it's just going to be beta minus gamma. We're using a lot of Greek letters now, but hold on. It's all right. It's all right. All right. So here's what we have right here. Let's look at the small triangle, the gamma triangle. So the tangent of gamma is 40 divided by 50. Opposite over adjacent. So if we wanted to find what gamma was, right, that's going to be the inverse tangent of 40 over 50. And again, the only time you'd really have to use angle sum and difference is if you wanted to find an exact answer. But in applications, we always care about approximations and applications anyway. So likewise, right, now we need to find big boy beta. So the tangent of beta is the opposite, which is 47, divided by the adjacent, which is 50. So again, big boy beta is the inverse tangent of 47 over 50. So now alpha is just beta minus gamma. Okay? So beta is the inverse tangent of 47 over 50 minus gamma, which is the inverse tangent of 40 over 50. And big warning, make sure you're using either degrees or radians and know what you're using. For applications, degrees usually makes more sense. All right? So we type that into our calculators. The inverse tangent of 47 divided by 50 minus the inverse tangent of 40 over 50. And we get 4.5687 degrees. All right. And every time you're doing an application problem, you should say, does this make sense? Well, these two are kind of close to each other. Angle should be pretty small. 4.5 degrees is pretty small. This is on the small side of what makes sense to me. So yeah, sure. I believe it. Again, it's really, really often that I'm grading exams and it's like, you know, you got a ladder propped up against a house. What's the angle of elevation? And people give me that the angle of elevation is like 1/2 degree. No, if your angle of elevation is 1/2 degree when you're propping a ladder up against the house, it's not going to work, right? So make sure that your answer kind of makes sense in the context of a problem. Okay, so between these two guy cables, it's probably a pretty small angle because they're pretty close to each other where they end. All right, and that's it. That's 9.2. Okay, so just kind of looking at the homework for 9.2, right? Essentially, find exact values. We did this. You just write these as the angle sum or difference of angles that we know about. Here, again, just angle sum. Here, angle sum, etc. I don't think I asked you to do those ones. And then over here, prove the identities. Start with one side and use some identities to turn into the other one. So like for 47, which you don't have to do, you'd say, okay, let's use angle sum on that and see if we get something like this. And you will, because remember, tangent of pi over 4 is just 1. So this is directly just using the identity. All right, so it'll be fun stuff. And as always, I cannot stress this enough. For my online class, if you have questions on the homework, if you're stuck, you can email me this, okay? I can give you hints. I can tell you how to approach it. We can figure out what's going on. So don't hesitate to email me about homework questions, all right? There's not that many of you. I think I can do it, all right? So hopefully this answers some questions. Go ahead and get started and have a good spring break. Yeah, bye-bye.